Hola! And in this video, we're going to talk about solving polynomial functions. We're going to take some pieces from synthetic division, long division, and graphing these different functions and apply it to solving them. In a previous unit, we talked about how to solve quadratics. So given this function, x squared plus 8x plus 16 equals 0, and the instructions find all the roots, we will simply solve by using whatever method we wish to find the roots, or the x-intercepts, of our graph. So how I'm going to do this is I'm going to factor, which it factors down to x plus 4 and x plus 4. Using the zero product property, we can set both of these factors equal to 0. As you can see, they're the same. And when I solve, I get the roots x equals -4 twice, making this type of solution a one real double, which when we look at our graph of the function, we see how our parabola simply touches the x-axis and bounces back. So now let's take this a little further. Let's have the example x cubed minus 3x squared minus 3x plus 9 equal to 0. Once again, find all the roots. So our first step here is to identify one of the roots by graphing. So we'll take our calculator and we will plug in our function here. And when we graph, we'll be able to see where our function crosses the x-axis, or we can hit second graph and go to the table and see that our function crosses the x-axis at 3, because when x is 3, y is 0. So we're going to use the root 3 and apply synthetic division to simply simplify our equation down further to a form we can solve easier. So once again, all I'm doing is synthetic division. And notice that the remainder comes out to be 0. So based on the remainder theorem and the factor theorem, when I have the remainder 0, that means 3 is a factor, which makes sense because we found that factor in the calculator. So one of our roots is 3. Well, now we have factored out that 3 root and have gotten the polynomial x squared plus 0x minus 3, which, and we say that's equal to 0, which we know how to solve. I first add 3 to both sides, and then take the square root, and I'm left with x is equal to plus minus -3. So the roots in my polynomial are x equals plus or minus square root of 3 and x equals 3. Notice I have 3 solutions, and looking back at our polynomial, my degree of the polynomial was 3. So since the degree was 3, I'm given 3 solutions. So let's look at a more involved example. So, given the polynomial x to the 4th plus 6x cubed plus 17x squared plus 12x minus 36. Once again, I'm going to, in the calculator, put in my polynomial so that when I graph it or go to the table, I will be able to identify one of the roots I would recommend going to the table first instead of waiting on it to graph. So from here we see that negative 3, 0, is a root. So using negative 3, I will apply synthetic division. And if you struggle on the synthetic division, I strongly encourage you to watch the previous video on synthetic division. So based off this, we see where we affirm that negative 3 is a root, and we have x cubed, and we factored it down to x cubed plus 3x squared plus 8x minus 12. So here is a lot like a polynomial that we saw previously. I would once again need to go to the calculator, put in my polynomial, and identify a root. So we see here that make sure you put it into the calculator correctly. So from here we see once again, make sure you put it in the calculator correctly. We see that 1, 0 is a root. Now, since I knew that 1 was a root ahead of time, I was able to go back and make sure that my equation was correct. However, you all might not have that intuition. So when you get down to this point, you will find that the remainder may not be equal to 0. If that is the case, you need to go back and make sure you put the equation in the calculator correctly. So once again, from here I see that x equals 1 is also a root, and I'm left with the equation, or polynomial, x squared plus 4x plus 12 is equal to 0. Once again, my equal to 0 is not from my remainder, but rather from the original problem. So from here, a quadratic, we know how to solve this. You can pick factoring, completing the square, or quadratic formula. In this case, this is not factorable, and so I will solve using the quadratic formula. Opposite b, plus or minus the square root of b squared minus 4ac, all divided by 2a, which when I simplify down will give me the square root of negative 32 divided by 2. And I can simplify the radical further to say 4i square root 2, because this negative 32 breaks up into 16 and 2, and 16 is a perfect square, which the square root of 16 is 4, is how I got the 4, and then the negative is how I got the I. And I can simplify further by saying negative 4 divided by 2 gives me a negative 2, and 4 divided by 2 gives me 2, and the I and square root of 2 remain. And so now I have the factor negative 2 plus or minus 2i square root 2. So this may seem a little more involved, but when we get with these higher degree polynomials, we find that we get a little more complicated. So notice here, the degree of this polynomial is 4, and I have 1, 2, 3, 4, because of the plus minus that makes this 2 solutions. I have 4 roots, 2 real and 1 that is imaginary. The last thing I'm going to show you, and I apologize for the length, is I want to show you a special type of polynomial in a way we can solve it. Given the example x to the 5th minus 11x cubed plus 30x equals 0, I see that each of my terms has an x. So a greatest common factor here would be x. So I can factor out an x from each term, leaving me with x to the 4th minus 11x squared plus 30. Once again, I'm going to leave my x out in front, and notice x to the 4th and x squared. Well, I'm going to substitute and say that a is equal to x squared. So I then can say that x to the 4th can be rewritten as a squared, because a squared would be the same as saying x squared squared, which is just x to the 4th. So I'm going to substitute in everywhere I see an x squared for a. And from here, I can factor normally. And so I factor this down to get a minus 5 and a minus 6. And then I substitute the x squared back in for a. And then once again, I set all of these factors equal to 0. And solve. So x equals 0 is already solved, and that's a root. And then I'm left with x squared equals 5. X is equal to a plus or minus square root 5. X squared is equal to 6. I add 6 on both sides, and x is equal to a plus minus square root 6. And I'm done with finding all of the roots. Once again, notice a 5th degree polynomial gives me 1, 2, 3, 4, 5 roots. And that wraps up solving polynomials. I apologize for the length and know that these problems are a little more in depth, but we have the pieces with synthetic division and graphing to be able to solve them effectively. Thanks for watching. Adios.